Alrighty, remember, you may have made a mistake, so be prepared to make corrections. If I'm going to draw a height versus time graph, no, Eckham, you keep coming in the door because class has started. If I'm going to make a graph of height versus time for a child on a swing, do I need that or just that? Left or right? I only need the one on the right. Why? Pardon? But height and time is comparing two things. Isn't that X and Y? Isn't that just comparing two things? Can. Time cannot be negative, and height cannot be negative. She is not swinging so violently she is digging a hole in the ground. And somebody always says, what about that little thing where their feet go under on the ground there? You will notice that the height of the swing is not getting any lower, is it? Good. What goes down here? Time. What goes over here? Height. If you have that, you would get 1 out of 2. At time 0, what is the height of the swing? 0. The swing is sitting on the ground. That makes it hard to swing. The swing is a little bit off the ground. Excellent. Now, how do you start swinging? You stand up, right? And the swing is attached to your butt. Has the swing gone up? How far? Very little. Then you lift your feet off the ground. What happens? The swing goes back down. Does it ever go below this line? No, not unless you are stretching the chains, which you are not. So, you go back down to that line, and then what? Goes up where? How high? A little bit higher if you know how to swing, or if you are lazy and you have your dad or mom pushing you. I stopped pushing my kids on the swing when they were like 3, because it's not rocket science. I see parents pushing like grade 8s now. Kind of makes me angry. Am I moving fast? At the beginning? No. So am I changing height a lot in a little bit of time? No. What will happen to this up and down action as I continue along in time? Jesse, it will go higher and steeper. Will it ever go vertical? No. Will it ever go around? No matter what your grade 6 cousin told you when you were in grade 3, you cannot swing the swings around the bar. It is impossible. All of you had a story from a big grade 6 cousin who said, this kid at my school swung right around the bar. He didn't. It's impossible. Now, somebody always draws this. Because the swing goes back and forth. If I walk around, will I see that drawing? I better not. Because what would I give that? 0. Why? Time doesn't go backwards. Again, no matter what your grade 6 cousin said, this kid in my school swung so fast, he went back in time. Because what does a graph do? Draw what is happening or represent data? It represents data. Excellently done. You know, it's awfully selfish that you just bless yourself. You could give people a chance. I mean, I, of course, know that there is no bad spirits entering your body when you sneeze, so you need not be blessed. But I don't know if any of you have seen it, but there's an internet thing about comparing farts and sneezes. And it talks about sneezes first. So when you sneeze, a few things happen to your body. One, technically, for a millisecond, apparently, your heart stops. Technically, I have heard. I don't know if this is true. But what is true is you spray snot and spit all over your hands in the air because you don't catch it, or worse, you do the vampire sneeze. So now your elbow is covered in spit and snot, which you cannot wash because it is on your shirt or on your elbow. And when you go to the bathroom to pee, you wash your hands. You do not wash here. So really, you're better to sneeze in your hands and then go wash them. But that's another story for another day. So your heart stops, apparently. You cover the world around you with spit and snot and germs. And when you do it, everybody says, "Oh, are you catching a cold? Bless you. Oh, are you okay? Oh, oh, oh." Now, let's compare to a fart. Feels great. Smells to you great. Completely harmless to everyone around you except a small little bit of methane gas leaves. I just breathed out some gas. Everything's okay. But when you fart, "Oh my God, you're so disgusting. I don't love you anymore. I want a divorce." You tell me, why? Why is sneezing our favorite thing, but a fart, you throw the person out of the room? Now, the original thing I saw this on was a gag on Facebook, which I have since been informed isn't technically a meme, even though it's an idiotic joke online. And the reason I find it funny is because at the end of the fart one, it says, "I don't love you anymore," and "Matt, I want a divorce." And of course, that is my name, and the first time I saw it, I was sitting beside my wife on the couch. I hadn't just farted, but it would have been funny if I had. What are the chances?
I will make sure to change.
No, Hazel, I'm just kidding. I was just doing a bit. It's just to make everyone laugh. It's morning, so I didn't get the usual response I get. Had I done this gag yesterday, last block, man, you guys would be rolling in the aisles. But it's morning, so I'm just getting a few polite snickers, some grins, a couple of, "I can't believe he said fart in class." Fart, 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 fart. All right, back to math. Distance versus time. Where's time go? On the bottom. Where's distance go? On the vertical axis. How does a race start? A 400-meter race. How does it start? Manru. You start at 0 this time. Excellent. Because I have gone 0 distance from the starting line, unless I'm a cheater. Right? For all of you to beat me in a race, you'd all have to start here. But that's okay. I'm just kidding. Some of you are probably faster than me. But seriously, folks, how does it start? Manru? It goes in a straight line? So when you're running a race, you just run at the exact same speed the whole time. That's not a good way to win. Eka. So, okay, but this isn't going to do acceleration. This is distance and time, not speed and time. You're on the right track. Ken. Right, so
towards the end of the race, you're going a lot faster.
You're going to want to speed up at the end to break through that tape, yes? Most likely, you're going to start slow, too. So you're going to start slow, then you're going to speed up, cover more distance in less time. And then what are you going to do at the very, very end? Hopefully, you have some gas left in the tank for a quick little sprint, right? Does it ever go back to start? But the track is a circle. So why doesn't this go back to start? Because I'm comparing distance. I ran 400 meters. So it can only go up because distance is scalar. Yeah? Now we change it. What's this one going to be? Yeah. Similar line, not going too fast, kick it up a degree. Then it would just come back down, and then hopefully steep. That's good enough. Technically, it's not, is it? Because technically, it's an oval track, yes? So at the beginning, you're going away very quickly. But here, you start slowing down in how far you're going away, right? Does everybody see that? Because it's no longer a straight line, yeah? You're probably about 50 meters technically away. Now, technically, this little bit is shorter. Or you could argue, yeah, but Mr. Myers, you've still traveled that 100 meters, right? Both of them would be correct technically. The point of this is its displacement, and you had to remember to come home halfway through. That's all I'm really going for. And lastly, what's weird about the way I worded 8? Position time graph. As you travel to school. Should it ever go back down? Never? None of you have ever left your house, forgotten something, and gone home for it? You guys are the honors kids. You don't forget stuff at home. I know you do. Everybody does. Without bragging, I'm one of the smartest people I know. One time, when I wanted to go surfing, I had to leave my house in Chilliwack 4 times before I was able to actually drive to the surfing city. I drove away. Oh, we forgot this. I drove home. Drove away. Oh, we forgot this. I drove home. Drove away. Forgot. 4 times. And it was not the first time I'd been surfing. I know how to surf. I know what I need. All right. So, because I said position, that means where I am relative to home, right? So if I did go back home for anything, there would be a dip in the graph, yeah? But it would still be distance and time. Now, obviously everybody's graph is going to be different, yes? If you walk to school, do you cover a lot of distance in a little time or a little distance in a lot of time? Right. If you take the bus to school, the school bus, what does the line look like? Zigzaggy, because it stops all the damn time. Right? If your mom drives you to school, or your dad, or your older sister, or your uncle, or your second cousin twice removed, I don't care. Would it be a similar line to the school bus line? Still stopping at red lights and stop signs and such, but not at every, third house to pick up some kid, right? If you ride your bike to school, would that look more like the walking line or the driving line? The walking line, but slightly steeper or shallower? Steeper. Why? Because you cover more distance in less time. Everybody understand? So for me, I leave the house 10, 20, no, that's too much. 3, 6, 9, up to 30, because 30K to the house. My distance is in kilometers. How do I start? Slow, because I live in the middle of Chilliwack, right? Takes me 8 minutes to get to the highway. The highway is 8 kilometers from my house. So from 0 to 8, I'm going to have a little few zigzags, whatever, blah, blah, blah there. What happens at the highway? It's going to spike. Why? Because now I'm going 120 kilometers an hour instead of at best 50. Right? Is it pretty constant? Highway in the morning? Sure it is. So at 8K to 27K, because that highway's about 2K from here, it's going to be pretty straight, yeah? 8 minutes. I'm going 20K almost exactly down the highway at 120 kilometers an hour. How long does it take to go 20K at 120 kilometers an hour? You shouldn't be saying like. 60 kilometers an hour is 1 kilometer an hour, yes? Or 1 kilometer per minute, yes? Okay, so what's 120 kilometers an hour? 1 kilometer every... It's slower? There you go, 1 kilometer and half minute. I'm going 20 kilometers. So how long do I drive on the highway? 10 minutes. So from 8 up to 18, it's going to be a pretty straight line, yes? Because for the most part, it's constant speed. What happens when I exit the highway? Slows back down for the last couple of K. Flat, couple of stops for lights. Maybe I get some gas, long stop, and then I arrive at school. That's me. All yours will look different. Yes? All right. Okay. The lesson today literally takes 2 seconds. So I'm going to do that lesson. Figuratively takes 2 seconds, not literally. I'm going to do that lesson, then you're going to work on a bunch of textbook pages because you need to practice this. Because it can be a little counterintuitive, right? All right. Page 196. I know it's a long way away, but as you flip through those textbook pages, you notice that there is crap tons of pictures and charts, right? Take up a lot of room. So, very few questions. Looks like a lot of pages. All right, here we go. What are the 2 things I'm counting on in that paragraph? I'm counting cost and I'm counting time. Which is the IV? Which is the DV? Time is the IV. Cost is the DV. Why? Pardon me, Anu? Time is for everybody. Better. A better definition is because the cost that I pay depends upon how much time I rent the car. Okay? So, what's going here? What's going on the vertical axis? Cost. What's going on the horizontal axis? Time. What is cost measured in? Dollars. What is time measured in? Days. How many days do I need? Why only 7? Because I only have data for 7 days. Agreed? Cost. Let's go up by 50. Yes, Hazel.
If this is additional day up to a maximum of 7 days, is the 7 days added to the first 3 days, or it is 7 days in total?
We're getting to that. All right. I walk into budget. I look at the cars. I do not rent a car. Everybody understand? I'm not happy with the cars. I'm not happy with their rates. Where's the first dot on my graph? 0 time. What is the cost? It is 0, right? I walk into budget and I say, I need a car now. Give me the papers. 1 second after arriving. How much am I paying? 65. So can I put a dot at 0? 0, 0. No. Because if I walk in and say, give me that damn car in 1 second, I'm paying, aren't I? So how do I show that on a graph? Don't draw it, talk. Open dot, where? 0 what? You need 2 coordinates to put something on a graph. 0, 65. Open dot. I'm going to make that a little bigger so it's easier to see. Screen's dead again. Although, again, you don't need to see it because we just described it. You put an open dot at 0, 65. You do not need to see that. You're in the 10th grade. You know how to graph. From 0 days, 1 second into that first day, to 24 hours from that first minute, second, I say, give me a car. How much do I pay? Do I ever pay more? Do I ever pay less? How do I show that on a graph? Flat line. Why? Because there's no change occurring and time marches on. Just like Metallica says in the excellent song For Whom the Bell Tolls. If you haven't heard it, I feel bad for you. It's one of the greatest songs ever. What kind of dot goes there? Closed dot. Because up to and including 1 day, I pay $65. Budget opens at 8 a.m. At 2 a.m., I was still out driving around my convertible Mustang. I was having a good time. Do I get that car back by 8 a.m.? No. What happens at 8 a.m. and 1 second? I'm into the second day, so how much do I pay? 65. But I've already paid 65, so where does this next dot go? 130. Is it open or closed? Open. Because at 1 day, I only pay 65. What happens at 1 day, 1 second? I pay the other 65. Till when? Till day 2. Closed dot. What happens on day 3? I go up to 195. Now what happens on the 4th? I only go up 30. So I go from 195 to what? Oh, addition. I know. It's killing you. 225. Then what happens on the 4th day? 255. What happens on the 5th day? 285. What happens on the 6th day? 315. And there I must stop. Why? That's where my data ends. Now, question 1. Should I connect the points? Well, let's talk about our options. Is that an option? Why not? It's going through the non-included dots. Okay. I got you, Myers. Who you kidding? Is that an option? Why not? Could I have rented the car in here? Is there input from 0 to 1? According to that line, is there any output from 0 to 1? No. So it can't be that one. Now, all right, Myers. That one. Yes or no? It's the only other option. Why not? What does time do? According to the Metallica song from 1987 called For Whom the Bell Tolls. Time marches on! What line are all those? Time is stopping. What does time do? Time marches on! Again, if you haven't heard the song, the gag is lost on you. But it's a great song. I should make it your homework. What are you listening to that noise for? Mr. Myers said it was homework. How is that math? We're trying to work out the time signature. Those of you who are in math or in band know what I just said. Those of you who aren't are like, you're whating? It's very difficult to work out the Metallica time signature. It's very fast. All right, so, no. But why not? Question 1, no vertical lines. Time marches on. 2, diagonal line through here. What does that mean? What does this line mean? It means I'm paying a different cost throughout the day. Am I? No. I can pay 65 or 130. If I input 1.5 days, I am not paying some output between 65 and 130, am I? So, we cannot connect the dots because the inputs are whole. I shouldn't say whole. The inputs do not include fractions of the day. Since there is no input for fractions of the day, this also means what? There's no whats? No outputs between what and what? Between 65 to 130, etc. Right? Everybody understand? Is it a function, though? Is it a function? Yes, of course it is. Why? If it's graphed, vertical line test works. But what if I didn't make this graph? Is it a function? Yes. Why? Each day produces one result. Each input, which is a day, gives a unique output, which is what? A cost. Does everybody understand? Okay, now this is where it gets a little weird. What is the domain and range? Domain, range. What's the domain? Zero is less than days. Why is it less than and not equal to? There's no output for 0. I don't pay anything at 0. Then what? Sure. Let's go in here. Less than or equal to 7. Now, here's where it gets weird. Can I input half a day? If I tell you I rented the car for 2.5 days, can you tell me how much it will cost? You can, can't you? Right? It's going to cost me how much money? 195. Yeah, it was 195. Exactly right. Because 2.5 days goes past the second day, yes? So I can enter 1.5 days or 2.5 days, right? So really, my domain days are a set of real numbers, right? Every number from 0 to 7 I could enter and get an output. Yes? Everybody cool? All right. What's the range? $65. What's the, what? It goes up to 315. That's what 7 days is. So how do I write that? Less than cost. You're happy with that? You're happy with that? You're happy with that? Please pick up the hint. No, of course you're not. Let me say a number that is between 65 and 315. 203. Will I ever pay 203 for this car? No. So are you happy with that? No. What is it really? And then 130. And then 195. And then 225. And then 255. And then 285. And then 315. Right? My outputs are not what? What is a word that you would use to describe those outputs? I would look at the title of this page. The outputs are not continuous. Are the days? Yes. This covers the days, and the days are a set of real numbers within those parameters. Yeah. Well, no. All right. So, you have two choices: discrete data and continuous data. Discrete data is counted. Continuous data is measured. Does everybody understand the difference? Let me give you an example if you do not. How many fingers? Discrete or continuous? Discrete. 1, 2, 3, 4, 5. You cannot measure my amount of fingers because there is no measurement of finger that is anything between 0 and 1, 1 and 2. Everybody understand? My height, discrete or continuous? Why? You can measure my height. Every fraction of available measurement is available to you. Eventually, we run out of words for it. But could you cut that last smallest distance into a smaller distance? Yes. Now, somebody always says, Well, if it's continuous, it must go forever. Do I grow to an infinite height? No. Discrete data is counted. Continuous data is measured within the parameters of the data. So, is my height continuous? Yes. Between the parameters of normal human height. The tallest human ever was something like 8'4" or something. I can't remember. His name's Robert Wadlow. He's crazy tall. You've seen pictures of him. He's from the early 1900s. He couldn't walk. They had to build cages to hold him up because his body was too big for his bones and muscles. The tallest woman ever was 8'1" tall. Zheng Jillian from China. I used to read a lot of the Guinness Book of World Records in silent reading, like all guys do. You remember silent reading in elementary school? It was a race to get to the Guinness Book of World Records, so you could look at the pictures of the most pierced man and the longest fingernails. Not to actually read. You were looking at pictures. We aren't stupid. We know that's what you were doing. But you were doing it, yes? So, even though there is a range into which the data must fall, it is still continuous within that range. Everybody understand? If you gotta count it, it's discrete. If you've got for lack of a better word, a range, even though it's not domain and range, it's most likely continuous. Everybody cool? All right. Let's look at a few examples. Number one, you're going to do two things. You're going to tell me the dv and the iv, and you're going to tell me if it is discrete or continuous, and you're going to explain it. Do number one. Go. Talk amongst yourselves. It is not a test. Brains work better together. All right, IV, DV. Let's talk turkey. Let's hear your...
Please excuse this interruption. Could the students going on the Playland physics trip please come to the main entrance? The students going to Playland...
Next year, guys, relax.
At the main entrance.
I wonder if they've built the new roller coaster yet. They got rid of the corkscrew. The red and white one that's at the very bottom, the back of Playland, underneath this big swing. Yeah, because it sucked. It's the stupidest roller coaster in the world. It didn't go fast. It didn't have enough upside down stuff, and you were too strapped in to enjoy it. It was lame. The roller coaster they replaced it with was the greatest roller coaster at Playland. You sat in a little car, 5 people, no seatbelts, no bars, nothing. And it went so fast, your face went like this. But then at the end, there were air brakes. So you'd fly into the end, and then you go, ba-bam! And you'd smack into the person in front of you. And people kept breaking their collarbones and knocking out their teeth and busting their noses on people in front of them, on the back of their heads. So they had to get rid of it, because North Americans are too wussy to have a ride that's wicked like that. It was called the Jetstar. Ask your parents. They'll remember it. They might remember it as the stupid name that they gave it for the last year of its life when 7-Eleven sponsored it, and they called it the Super Big Gulp. It's the dumbest name in the world. Jetstar was so wicked. Then we arrive at Playland the next year, and it's, you want to ride the Super Big Gulp? No, I want to ride the Jetstar 2 because it was the Jetstar 2. I don't know what the Jetstar 1 was. Usually sequels are worse, but the Jetstar 2 kicked ass. Anyways, if your parents grew up in and around Vancouver, ask them about it. See if they remember it. It was the best ride ever. I lie. The Wild Mouse was the best ride ever. Jetstar was second best after the Wild Mouse.
All the roller coasters that play that are like crazy.
Yes, as they should be. Yes. Yes.
Like they're
I'm aware of that, Hazel. Roller coasters should be creaky. Here's why. Wood doesn't break. When you look at wood, you know when it's about to break. You can replace it. You know when metal breaks? You have no idea. Metal goes through what's called fatigue, and it can look perfect, and 2 seconds later, it can explode. Metal roller coasters are evil, dangerous, lame, and boring because they're too damn, the illusion of safety is too strong. Now, back to math. IV or DV? What's what? The IV is the room temperature, and the DV is the speed of sound. Absolutely correct. Why? But why? Ekam. Again, why? Okay, I'm going to ask you to do something that is almost impossible. I'm going to ask you. It is almost impossible. I'm going to ask all of you to do this. Don't make a sound. I know, it's impossible. Somebody always thinks they're funny. And you're still making sounds. If all of you were capable of actually shutting up for 5 seconds, would this room continue to have a temperature? So when you all shut up, the room plummets to absolute zero and all matter of motion stops. I'll ask again. If you could all be quiet, would this room continue to have a temperature? Yes, yet no sound would be passing through it. All right. Discrete or continuous? Continuous. Why? Time is measured and speed is measured. Meaning we can have fractions of both of those. Seconds, milliseconds, nanoseconds, picoseconds, so on, so on, so on. Centimeters, temp. Not time, temp. And speed. Temperature, degrees, and then every fraction thereof. Excellently done. Number 2. IV and DV. Talk amongst yourselves. And 10, 9, 3, 2, 1. What's the IV? Age. What's the DV? Dose. Why? The dosage depends on how old you are. Right? Right? You all have looked at the side of a medicine container. Under 12, do not take unless consulting a physician, which is, of course, all of you were taking cold medicine long before you were 12. Over 12, you take a different amount. Right? Okay. So good. Everybody's cool. Discrete or continuous? Discrete. Why? Your pills are counted. You do not get out, and your age is counted. Now, some of you will say, no, it's not. I always have an age, Mr. Myers. You're right. You do. How old are you right now? Who do I want to pick on? Anu. Really? Your birthday was 1 second ago? No, how old are you? Your birthday was 6 months ago exactly? Your birthday was November 9th? How old are you? No, what's the point? What did he say? 15, right? What's the next number he's going to say? 16. The only time you ever use fractions of age is when you're 4, or when your teacher's making a math joke the day before his birthday when he says, I'm 43 and 364 365ths. Nobody does that. We count our age, don't we? Excellent. Pills. I am 12 years old, therefore I need to take 1 cold pill. Tomorrow is my birthday. I am 13. Therefore, I need to take 1 cold pill and 1 365th of the next cold pill. Is that the way we do it? No. Do your parents get out a rasp and file off a bit of powder from the vitamin when you're a day older? No. They give you 1 more pill. Aight? Aight. Number 3. Go. IVDV. I know. That's why all of you were able to take cold pills before you were 12. It's just a legal thing because some kids react badly to medicine. IV. Cans. DV. Cost. This one always creates much argument. But if I don't pay any money, I haven't bought any cans. No kidding. But you did buy a box of Ritz crackers, some bacon, maybe a block of cheese. But the only 2 things we're counting here are cans and the cost of the cans of juice. So, how much you pay for cans of juice depends upon how many cans of juice you buy. How much you pay for cans of juice does not depend on how many blocks of cheese you buy. Okay? Okay. Discrete or continuous? Discrete. Why? Cans are counted. What? Of course they are. You cannot go to Safeway. I'm only half thirsty today. I would like 1 can of orange juice, which I will take out my knife, cut in half because it is frozen. I will take half of it, and you will give me back $1. Because it was $2 for the whole can, so I only want a half a can, so I should only pay $1. Can you do that? No, you can only buy 0 cans, 1 can, 2 cans, and then, of course, you see the bird with the funny beak. 2 can, nothing. It's on the Fruit Loops container. Fruit Loops are disgusting. My kids used to always ask, Dad, can we get some Fruit Loops? Dad, can we get some Fruity Pebbles? And I'd always buy them. And they'd be like, Dad, these are gross. I'm like, I know. And then the next fruity cereal would come out. Dad, can we get some Fruit Blasters? No, because Fruit Loops, Fruity Pebbles, and every other fruity cereal stays in the cupboard until it grows. You don't eat it. You just want it because it's colorful and fun. Fruit Loops has one job, to make those necklaces that you guys made in grade 3 that you brought home to your parents. And they said, oh, it's so beautiful, and waited till you turned away and threw into the garbage. Because when you make something with food, it cannot last forever. Same thing when you brought home a macaroni necklace. I know, it's hard for you to hear these things. It's true. It was a purse made out of... You made a purse out of leather and your mom threw it away? And you bedazzled it? Yeah? That's hardcore. All right, last one. Which is which? DV is temp. IV is alt. That's what you're saying? Of course the temperature depends on altitude. Is there snow on the ground here? Is there snow on the top of Mount Baker? Is the top of Mount Baker on our planet? Are we on our planet? What is the difference between us and the top of Mount Baker? Altitude. Discrete or continuous? Continuous. Why? Because altitude is measured. Temperature is measured. Even if we run out of names for the fraction, it's still a fraction. Okay? Are you dancing or is she harassing you? Okay. Alright, we're done. That lesson took a little longer than it should have due to playland discussions and things. You need to work on pages 188 to 195. No, not for tomorrow. What is happening tomorrow? Cumulative exam on units 3 and 4. Now, if you look on the back board, there is a good little extra review for cumulative exam 3 and 4. The only thing missing is any division of radicals, which I'm about to go back there and write right beside multiply. Okay? When do I expect to see sum of 188 to 195 done? Monday. Tomorrow you're writing a test on that stuff. I'm going to go back right now and put up some divided by radicals. Now, all of that stuff, you will be able to see the right answers because I will tack it on to today's video. Okay? Okay. I won't be talking through it. I'll just be doing it. Aight? Aight. Your choice for what you do for the next 25 minutes. You work on that, or you work on this. There's the third choice that is the one you're all actually going to take, which is do nothing and talk to your friends. Then, of course, I will have, if we were to graph my sympathy for you, when you don't get the grade you want over time, at 0 time when I first met you on February 1st, it was way up here. 1 day later, it was down a little. 70 days later, it is now here. And it is continuous data. Because time will march on and I will always have some level of sympathy for you. Right now, it is 0. Because any chance you have to work, you do not take it.
Probably is.
Ladies and gentlemen, if you are looking on the back, the cube root of 360, but it's 4 root 162. Okay, the 3 with 360 is an index. The 4 with 162 is a coefficient. And the 3 with the other one is an index. Yo. You go, girl.
You're in school because of him, Harry.
You just don't care. What'd you get for the GCF? Most times I do. But then you can, or a video of you performing down here. No, I'm not. I said to a girl, your eyes are like glossy eyes. Like eyes are what? Is it 12?
Yeah.
144 months. The GCF is 12. Oh, no, that's what they go into, isn't it? Right? I'm sorry, they're just a little threatening, that's all.
Oh, it's the H of the helicopter. Of course it's me. Yeah. Do I? Oh, like 3:30. Yeah, something like that.
interruption. All grade 8 tours should be back in the rotunda now. All grade 8 tours should be back in the rotunda. Thank you.
You're crazy. That's not what? Yes. Thanks. Like, what do you mean free? How much food? That's what I thought. Yes, I did. I said that right off the bat. You have that done? No, I didn't think so. I did not think so. People who are smart can just usually higher than yours. And I don't actually and I shouldn't be that high anyway, so where? What? Why? Never mind.